Welcome to Decode It, a podcast series helping understand more about computer technologies and its beginnings. I'm Ashley Griffin, involved in IT from the 1980s, first with the Atari ST, then on to computer networks in the early 1990s. This episode is about the DNS server, that's Domain Name System. It was created in November 1983. Its main goal is to convert domain names into IP addresses. It started to be used when the internet was around in 1985. So there were more features added to the DNS server in 1987, so it was kind of fleshed out more. It can only be used on TCP/IP, so you have to have an IP address, either statically assigned to the system or via a dynamic assignment, so the DHCP server. It's only an IP-driven service. It uses a UDP port number 53. There's a bit of background to it and why it came around. So ARPANET originally started using the host file that still exists in Mac, Linux and Windows, and that started in the 1970s by John Postel, which was the University of Southern California's Information Sciences Institute, or ISI. It was maintained by Feinler, who was the director of SRI, Network Information Center, or NIC for short. You basically had to call in during business hours and add your machine name and the IP address of that machine, and they would manually add that to the host file. It was very man-hour intensive. It was highly manual. Finder then realized that we probably should have some sort of standard to this, so that's where they actually invented domains like .com. At that point it was .edu for education. They were maintaining the database for that, the Whois database, from 1972 to 1989, so I would argue fairly recent in the computer industry. Now, so obviously post that, then in 1987 the DNS server was invented to replace the host file as more of an automated system to stop you having to mechanically ring and update a host file. So there was a process in place. Going in parallel to this, not to be confused with the DNS server, is the Microsoft Win server. So that's the Windows Internet Name Service. That was invented by Microsoft in 1994, and it was first implemented in Windows NT version 3.5. That was used on the NetBIOS networking protocol, and again that's totally different from TCP/IP. It was the Win system would do name resolution on NetBIOS. It kind of got deprecated by the mid 2000s. I was doing migrations for companies in the late 1990s, and they were running three protocols. We had NetBIOS running, which was Microsoft. We had Novell IPX SPX, which was Novell's version of the Internet Protocol IP, and then they had TCP/IP, which is now TCP/IP version 4. So there was actually three network topologies running around the same company. Internet wasn't really around then, so you couldn't just jump on, find a podcast or find a YouTube and work out how to fix that or what the problems were. You had to ask someone and figure that out. So as a parallel, Microsoft Wins was exactly the same as DNS, but it was Microsoft's flavor of that to work on their NetBIOS networking protocol. So to come back to the DNS server, so the DNS server has records. Its primary job is to list the host name of your PC or a host name and resolve that to an IP address. There are different types of records, and I'm not going to go over all of them here, but you would normally have an SOA, so the start of authority. You would sometimes have a pointer record, which is the reverse. It's an IP back to a name. You have CNAME, which is canonical name, so that would be Domain.com resolves to domaina.com, so that it's basically a name to a name. MX records, and they were quite early, so that's mail exchange, so that's to identify where the mail server is. Then you have a record and a, which is the IP version 6. And then you have NS records, which are named server records. There's some fairly new ones after that, which were TXT, and I'm not really going to go into strong details of what these records are, other than I will probably reference the A record, the C name record, and the MX record a fair amount here. So, like myself, I use Windows a lot. I do use a bit of Linux. I also am savvy with Mac. Microsoft's war with the Win server being theirs and the DNS server, I remember this very well from the 90s. In which one do you use? Microsoft's domain server or Active Directory relies heavily on name resolution for a lot of services. So when you press Control-Alt-Delete to log in, it's looked up like where is the directory server to do that. And that would either be via Wins or the DNS server. Now, they moved to DNS server kind of in Windows 2000 or Windows Server 2000, which is kind of when that came around. And I'd remember that very well. You don't have to use... so a DNS server, the maker of the DNS server, obviously Microsoft have one that you can add into the Windows Server free. You don't have to just use theirs. I mean, Linux had Bind. There are a few others as well. So Simple DNS, which runs on Windows and is actually really powerful and quite good and has plugins with it. Also, a lot of you guys probably recognize Pi-hole. And Pi-hole is something written on the Raspberry Pi. It's a DNS server, but it's more used for ad blocking and control. Now, so the Windows domain needs DNS to work. So if your PC has been off the network for about 30 days, those records have timeouts on them called TTL, time to live. Generally speaking, a lot of those were set to 30 days. If you check Google set theirs to 5 or 10 seconds. I generally, when I'm creating DNS records on the internet, I set them to 60 minutes. Thereby, if I move an email server, it's the longest it's going to be is an hour before before the PCs see that change. So when you log into a PC, it's looking for the login server, and that's why if it can't find the DNS server, you have issues logging in. And sometimes you'll get an error that says unable to find login servers, and that was because it couldn't resolve that in the DNS server. So this leads me on to a couple of other minor things here. Windows has the ability of being able to assign 2 DNS servers, and I've seen this in a lot of companies that I've travelled through and doing migrations and assistance with. Generally, you find that they'll log the local server, so a DNS server can be anywhere on the planet. But if it's locally at, say, your 192.168.1 network, they will also then assign Google as a secondary, so maybe 4444 or 8.8.4.4. This seems like a really good idea, but actually it's not. So what happens here is specifically Windows. I would be fairly sure Linux is the same. I've not really tested it. With Windows, if it can't access the DNS server, so if the DNS server is offline for any reason, so it sends a request to check a name, and it doesn't get a response for that, so the server just does not respond, and the server will respond. It will either respond with I don't know what that is, or I have no answer. So if it doesn't get a response, it will then fail over to that secondary DNS, which a lot of the times is set to Google. Unfortunately for Windows desktops is it doesn't fail back until that server fails. Well, Google, unless you're offline or their server goes down, is never offline. So what happens here is there are some PCs that I've removed from site can't log in because they've not seen the local DNS server for weeks or months. It's been running on Google. and it's been running on cached entries. When there's a problem and I take it off site, those cached entries expire, and now it complains it won't get into the domain because the record has expired. So generally setting a secondary DNS server to something else other outside of your network is a really bad idea. If you're going to do that, you need two internally and maintain two servers. But really just make sure the one is working. There are reasons why you might want to. I have a couple of projects now that I am setting up a backup in case the first one goes down. So then we're not worried if it fails over because they're both live and they're both mirroring each other. But a DNS server can be anywhere. So your PC can be sitting at your house. You'll have an IP version 4 address, and that's that sort of 0.0.0.0 number. And they will go up to 255.255.255.255. The DNS server can be anywhere. So you can point it to Google, which is not on your LAN, and that will use the standard routing table in your PC to get to that server to resolve that name. Now, so to test this, I'm going to refer to Windows here. I do know that there are comparable commands on both Linux and Mac for this. But generally speaking, if you open a command window, so what you would have known as DOS, or you guys probably are more going commands, so CMD, if you were to just do ping, P-I-N-G, space www.domain.com, that will go to the system assigned DNS server in your IP address list and resolve that name. If you get a resolution for that name and that name's correct, then the DNS server is working. Now, we mentioned earlier that the host file was in use pre-DNS. That's still in use. Every Windows system, Mac system, and Linux system still has a host file. Windows, it's called host. That will do a record resolution. So you've got to be a bit careful here that there are some viruses put all their own names and IP addresses in that host file. So when you go to google.com, you're not going to Google because it didn't ask the DNS server for the IP address. It first of all looked at the host file, which was compromised by the virus or the hacker. So google.com may not resolve to Google. It may go to the hacker's server. So you have to check the host file, and if you think a system's compromised, that's the first thing you do is technically back up the host file or delete it. So you remove it from the system so you know that any DNS or any name that you're requesting is going to a real DNS server. Now, you need administration privileges to remove that file or rename it. It's kind of in a deep within Windows and deep within the Linux system. Generally, you would have to restart that for that to take effect. But ping space domain in a DOS window will, if you get a name resolution, that's a good test, and that's one of the tests that I use to check, is the DNS server answering, or do we have network connectivity on that PC, and is it all functioning as we think it should? Now, Microsoft do have actually a command system for checking name servers. In the DOS window again, so the command window, you would type ns lookup, so name server lookup. That will take you into a prompt that just looks like a square arrow, and you would just type in there domain.com, and that will go off to the DNS server and check that. The difference with that tool is you can query different records, so the host file will only host A records. You may want to test a domain record, or you may want to test an MX record, and that's generally what I end up using it for. And to do that, you would run a command called set and then a space q, as in the letter Q, equals MX. And then you would just type in domain.com. But instead of it going off to try and find an A record for that, so that name to an IP address, it will ask the DNS server for a mail exchange record for that domain instead. That's how you would want to query different records on the server without physically going to find the DNS server. I'd mentioned earlier that you can have any DNS servers anywhere on the planet. Well, you'd normally run your own DNS server if you have a Microsoft Active Directory, which would be a domain. So that's why Microsoft Active Directory needs its own DNS server. And that server runs on the normally the Active Directory controller. It can run anywhere, but it will update all those records with all the service records that the Active Directory needs all the PCs to see to log in and get access to the Active Directory. And there were a lot of records there, and from memory I think there was just under 30. It doesn't have to be a Microsoft DNS server. I have actually run a domain using simple DNS and it works functionally fine, arguably quicker. But what will happen here is when you send a request to the DNS server, it will look for a local record. If it can't find the local record, it will then go to the internet. So if you ask it for domain.com, that wasn't put in by the Active Directory, so it will go off to the master records and find domain.com for you. I'm not a lover of Microsoft DNS Server. There are bugs with it that people are aware of. Sometimes you end up needing forwarders for it, which work fine, so you forward them to Google. So that means, again, if it's not in the local DNS server, it will forward that request to an outside DNS server. It is what it is. You kind of live with what works, and then you kind of go from there. So that's a brief overview of the DNS server, and it is IP driven. Almost everything now is an internet protocol. You will need a DNS server. Now, if your PC is standalone, not in a domain, it does do some internal lookups, especially with Windows 10. Where you get an issue with things like Windows 10 is it's continually going off and checking Microsoft for Windows updates. Well, that's DNS server reliant. So if you don't have a DNS server, it can slow the system down because it's sending that request and waiting for a timeout. It is what it is. Android is now a web-based OS, so it's very web-based. You can't really get away from this kind of stuff. You do need a DNS server. There are other services other than the DNS server. There's DNS over HTTP. I'm not going to go into that here. So really, hopefully this has given you a bit more understanding of what the DNS server is, standing for the Domain Name System. It was very early, so it came out in 1983. That was when it was first ratified and put in place, and it was extended in 1987. So way before the common internet that most people would have seen have come around, and this was all over in California. So that's kind of where the internet started and kind of spawned out from there. So I'm going to be doing some more podcasts and some more of these technologies that are still used today, but people probably don't understand where they came from and why they come around. Things like FTP, File Transfer Protocol, the DHCP server, so the Dynamic Host Configuration Protocol. There's also a secondary Linux version of that, which is BootP. I'm going to be doing some more of this, and we'll be looking at some other older technologies going back to GEM, which predates Windows, and that's what Apple Mac had very early 80s or mid 80s. It's what the Atari ST had, and an IBM. They sold that with the IBM 1512 and 1640 as well, which predates Windows, and arguably probably is a lot more efficient than Windows. However, didn't have multitasking. Thank you for spending some time with me. Subscribe to see more in the Decode It series.